JA Solar keeps producing and promoting high-performance PV products. Keep innovation and persisting on the belief of customer focus. Keep improving for better solutions and harvesting more sunshine. Integrated with the belief of high efficiency, reliable, and environment friendly, JA Solar launched Deep Blue 3.0 modules with lower LCOE, but creating more customer value. Deep Blue 3.0 adopts 182mm large sizing wafers, which brings higher power generation benefits. The gallium doping technology has been fully deployed, which effectively mitigates the initial light-induced degradation, LID, and ensures high effective and stable power generation performance. The new generation Perseum Plus cells significantly improve power generation performance under high temperature operation environment and low irradiance condition power generation performance capability through optimized cells front and back service with passivated workmanship. And the mainstream mass production conversion efficiency of the cells can reach up to 23.3%. The optimized 11 busbar cell design shortens the current transmission distance, reduces the cell internal resistance loss, fully improves cell conversion efficiency, reduces the risk of micro cracks, and enhances product reliability. Deep Blue 3.0 adopts advanced module encapsulating technology, optimized high-quality encapsulating materials, half-cut cells series parallel structure, and the mainstream mass production efficiency could reach 21.1%. Diversified types of solar module design to match with different applications and meet the diverse needs of customers' requirements. Harvest the sunshine. JA Solar strictly focuses on the quality of its products as priority. We try to provide our best products for customers with spirit of excellence craftsmanship in each process and detail, which includes raw materials qualification, module design, manufacturing, quality inspection, and testing. Deep Blue 3.0 embodies the refined manufacturing process, leading-edge technologies, advanced devices of JA Solar. From ingot, wafer, solar cells to modules, JA Solar continuously carries out technological innovations to upgrade product property. Automated, intelligent, and integrated precision manufacturing facilities and excellent manufacturing capabilities proves the premium assurance for product quality. Refined manufacturing process and leading-edge technologies. Diffusion Plus SE, reducing the contact resistance between silicon wafer and electrode and the surface recombination. Alkali polishing, no nitric and no sulfuric acid without environment pollution. Integration of PECVD, aluminum oxide, and silicon nitride coating to improve the coating quality. Integration of laser slotting, printing, bifacial double measurement automatic packaging. Non-destructive laser cutting, effectively reducing micro cracks and leakage current at the cell cutting edge. Automatic overlap welding and automatic packaging facilities improve product quality and production capacity. Automation and intelligence, integrated precision manufacturing equipment and outstanding manufacturing capabilities provide an important guarantee for product quality. JA Solar high-quality products have been qualified by hundreds of technical tests and inspections, such as wet leakage current, hot spot endurance, strike impact, and accelerated aging to ensure high product reliability. Modules with 182 silicon wafer makes full usage of container space, reduced transportation costs, and easy for solar module handover. Harvest the sunshine. JA Solar always follows the principle of customer orientation and helps customers reduce the costs of solar system accompanying with more benefits. With the concept of green energy development being accepted by more people, PV power generation has been paid more attention within recent years. Deep Blue 3.0 has become the valued recognition of global customers for its excellent power generation performance. JA Solar continuously keep technology innovations and products upgrade by providing high quality, high efficiency, and aggressive cost PVC products to our valued customers and lighting up the new era of solar energy with lower LCOE solutions. Deep Blue 3.0, for now, and also for future. Harvest the sunshine.
Hello and welcome to this PV Tech TechTalk product series webinar co-hosted with JA Solar. The title of today's webinar is How JA Solar's Premium Modules Benefits Europe's Residential, Commercial and Utility PV Segments. My name's Liam Stoker and I'll be your moderator for today's webinar. And joining me today are Henning Schulze, Corporate Assistant President at JA Solar, and Ignacio Espinoza, Senior Technical Manager at JA Solar. Before we start, some housekeeping. Today's webinar will last around 45 minutes. Shortly, we'll have Henning, who will give his opening remarks, followed by a presentation from Ignacio, after which we'll pass the baton over to our audience, and you'll have an opportunity to quiz JA on the benefits that of the company's modules can deliver to Europe's 3 core PV segments. If you do have a question, please use the dialog box on your screen. We'll work our way through as many questions today as possible, but if we are unable to get round to your question, please provide your email address and we'll liaise with you directly. The slides and a recording of today's webinar will also be available shortly after the presentation. We will also be running a poll for our audience to participate in today, asking, as customers, what do you value most when selecting a PV module supplier? If you could answer that poll, it would be much appreciated. But without any further ado, I'll hand over to Henning to begin today's webinar.
Thank you, Liam, and hello, everybody. My name is Henning Schulze. I'm Corporate Assistant President at JA Solar, and I head our European business. I very warmly welcome all of you to today's webinar. Now, since we last held a webinar of this scale in the first half of last year, a lot of things have happened. For example, all of the major economies in the world, such as the US, the EU, Japan and China, have called for their carbon neutrality targets by 2050 and 2060 respectively. And in Germany, the Constitutional Court even ruled that the initial Climate Protection Act was not clear and specific enough when it comes to measures and targets until 2030. This has now led to a new version of the Climate Protection Act calling for carbon neutrality in Germany already by 2045. And the Greens, as one of the parties currently going for chancellorship in the September national elections, have set the target of 12 gigawatt of new PV installations per year. But also in other countries, we are seeing very positive signals. In Italy, for example, Mario Draghi has set the target of 70 gigawatts of new PV installations until 2030. And Poland, a market we were all waiting for a very long time, and a country still highly reliant on coal, has now become a gigawatt scale PV market, and we believe it will stay very robust and dynamic also in the years to come. We are entering into a new era of unprecedented demand with new business models to create and to serve this demand. The future will be solar. So how do we at JA plan to serve and to support this demand? It is our very clear strategy to stay one of the leading suppliers when it comes to product innovation, product range, product quality, and production capacity. And it's now my very big pleasure and honor to pass on the floor to my colleague Ignacio Espinoza, who in more detail will introduce to you the offerings we at JA have to serve the demand from the various market segments. Thank you very much.
Thank you, Henning, for your words. Well, for today, we have prepared a presentation which is showing how JA Solar premium module seats benefit the Europe's residential, commercial, and utility segments. We have split this presentation into 4 parts. The first one is why JA Solar is the best partner that you can choose for your modules. The second part is talking about the technology that we are using nowadays. In the third part, we are analyzing which is the best solution and why we are offering a solution for all the PV projects that you can face. And in the last part, we would like to talk about the M10 wafers and which is the reason why this is the right direction for the solar industry to move forward. Talking about JA Solar, there are 3 points that I would like to remark. And this is the first one, it's that we are a long-term player. Okay, we have been founded in May 2005. We are here in the industry for a long time. We plan to stay from the beginning to the end. It's true that 2005 could sound really modern, but it's not true because this technology it's also really, really modern. The second point is our strong presence that we are showing in European region. We are owning a market share above 16% of the market. This is because our interest, our efforts to help our customers here in this geography for their projects, and also the focus that we are showing for the distributor channel in this region. The third point is the bankability that we are showing nowadays and all in our history. We are one of the brands, the top bankable brands in the last years, and this is really important for the customers and their projects, of course. Talking about the technology that we are offering, one of the best skills that JA Solar is offering to the industry, it's our high level of vertical integration. We are working in this technology from the wafers to the modules. We start as cell manufacturers, and it is helping us to understand the technology, to control the quality from the beginning, and also to control the cost from the beginning of the supply chains. This is really important for the knowledge of the technology, and it's one of our best values. The other key point is the capacity. Of course, you know that the industry have growth since long time, really massively. From our side, this year we are increasing our capacity by twice the capacity that we have last year. We closed the last year with circa of 20 gigawatts of capacity, and we are expecting to close this 2021 year by 40 gigawatts of capacity. It is allowing us to provide to the customers, of course, all the demand. And it's also important to analyze which is our accumulate power, because this is bringing us the field data of our products working worldwide in different environments, in different conditions. And it is bringing us the opportunity to analyze how the technology is facing different environments. We are one of the top 3 largest capacity deployed in the market. Our manufacturing bases, and they are all located in China, also in Vietnam. And as you can see in the picture in the bottom right, we are accumulating these big factories. One of them, it's almost reaching 10 gigawatts, and all the plants that we are having to increase the capacity for the following years. In the second block, talking about the technology, well, we have lived how the power have been increasing in the last years, including small upgrades in the cells, also in the wafers, and later in the modules. These upgrades, we can remark how we migrate, or we move from poly technology, polycrystalline technology, to monocrystalline technology, also including the PERC technology in all of our modules. How the half-cut technology also helped the module to manage a lower current inside the cells and therefore have a better performance. The multi-buffer technology is also helping the current to go outside of the cells and therefore improve the performance. At the end of the day, the aim is to increase the power output, as you can see in the chart in the left, and until the second part of 2019, it was made by small upgrades, small steps, working on the cells. But there is a limit in this growing curve of these P-type cells. And now to attend the demand of the market to reach more power output and therefore impact on the BOS cost of the applications of the projects, the only way was to increase the area of the cells. In that moment, the M6 wafers, based on 166 millimeter wafers, this kind of wafers were able to offer more power output and therefore keep reducing the BOS cost and increasing the power output in circa of 20% of the power. The next step, it was going to the M10, and that's why what JA Solar is doing nowadays, reaching more than 540 watts in their biggest models. Other important upgrade, talking about the technology, is the gallium doping technology that we are using in our cells. It is impacting on the degradation, on the initial degradation, the light-induced degradation that we can find in the modules in the first year, because it is helping to reduce this oxidation over the cells by 0.5% in this first year. This is really important because it is impacting in the yield on of the yield of the park for the rest of the lifetime. No, if we are reducing 0.5% the first year, it is impacting up to the performance warranty value of 25 years. It's also helping other technologies as well, such as the gallium doping, to reduce the yearly degradation. And nowadays, we are proud to offer 2% the first year, 0.55% for the single glass modules, and for the double glass modules, 0.45% for the yearly degradations. Also important to remark that the warranties for the double glass modules, it's reaching 30 years. So at the end of the performance warranty, both kind of modules, they are both reaching 85% of the initial performance. In this third block, we are talking about the solutions that JA Solar is offering for all the PV projects, especially for the European market. This is the most important part of the presentation. And in this first slide, we are trying to show which is our portfolio, our current portfolio. It's really difficult because it's really wide in the meantime. We can classify our modules in a small format and a large format. The small format, it's commonly understood as 60 cell modules, and the large format is 72 or even 78 cell modules. There are 3 different sizes of wafers nowadays available. Every single size of wafer is owning different characteristics and different benefits. For the 158 millimeters, the small format, it's reaching almost 350 watts, okay, and the large format, it's 415, as you can see. The S10, it's even more interesting in terms of the power output, different benefits. It's also available in a small and a large format. And the last wafer size that we are offering, which is 182 millimeters, it's the biggest cells that we are offering, and also different benefits that we will analyze in detail in the next slides. We are offering all of these products in monofacial and bifacial format, and all the wafer sites are also available with a full black series product, which is especially aimed for European market because of their characteristics or their benefits to be integrated into the residential segment. Of course, all of our products, they are all based on the latest technology. One of the most important points for us is the product reliability. This is really relevant for JA Solar. So we are only using very well-proved technologies, and we are only proposing products which are reliable proof. Okay, this is really a key point for us. All of them are using PERC technology, half-cut cell technology, multi-bus bar, and the gallium doping technology that I explained in the slide before. So we are aware that our portfolio is really wide. So our aim is to create a perfect solution, a suitable product for all the PV applications. If we are looking at the small and large format, we will find that probably the small format will be more focused on residential and commercial and industrial sites, and the large format, it's more focused for utility scale. However, you can use, of course, you can mix this understanding on the small and the large format in different ways. Now, this table it's trying to help the final user to understand which is the best usage of each product. However, every single project is different, and the understanding of the best solution to use in the project is also depending on the specific characteristic of each project. In any case, we are proud to offer the widest portfolio in the industry and a suitable product for all your PV application. Looking at the small format products, we are highlighting which is the major benefits of each kind of products that we are offering. The 158 millimeter wafer products, we call them JAM 60S10. 60 is the number of the cells. The benefits that it's presenting these products, it's really a very well-proved product. It's the smallest product that we are offering in our portfolio, so it is fitting in all roofs that you can find in the market, not only the roofs, also for ground system mounts. This product could be also used, but this is one of the major benefits. It's a light product, it's easy to handle, it's easy to lift the product to the roofs, to lift the product to the mounting systems. It's the largest track record. This product has been in the industry for several years, and again, we know how it is its behavior in different environmental conditions. It's really important also to remark how the aesthetics of the full black version, it's difficult to appreciate in this picture, but I really invite you to analyze how this aesthetics of the full black version, it's something that you can only use by seeing the model. In the second type of wafer, the 166 millimeter, we call them S20, okay? We are reaching more power with this product. It's 385 in the small format. This is the most selling product in the European distributor channel. It's bringing a big demand here. It's because of the good balance between the size of the power of this module. When we are increasing the wafer size, we are also increasing slightly the size of the modules, okay? The balance between the size and the power on these modules, it's really remarkable, and it's also available in a full black version. Based on 182 millimeter wafer, we are offering a new product. It's reaching 405 watts. It's compounded by 54 cells instead of 60. This is bringing us the opportunity to offer a lower open circuit voltage for this module, which is really interesting because we are able to reach a longer string length for the applications using these modules. As we know, this characteristic bring us the opportunity to reduce the BOS cost by saving cost in the wiring and also in the combiner boxes or even in the racking system. It's also a light product because of the frame. We are using 30 millimeter frame in this product, and this is bringing a low weight to this module. And another outstanding skill for this module is the area. The area of this module is below 2 square meters, which is really important in the European, in Central Europe, mainly because there are some regulations which is making easier the permits or all the permits for the applications on rooftops if the equipment used, if the modules used are below 2 square meters. So this product, it's directly aimed to the European market. Looking at the large format products, the first one, it's again based on 158 millimeter wafers. We are reaching 415 watts. It's called our S10, 72 cells. This is, again, the worldwide track record that this module it's owning. It's the largest. It is, the most used modules of our portfolio in the history. The data that it is bringing to us about the performance in different conditions, it's again really valuable for us and for our customers. It's a light and a small product compared to their big brothers, and it's a wider compatibility. It's something that it's again remarkable because the rest of the elements in the installation, I'm talking about the inverters and the mounting systems, they were primarily designed for this size of modules, and of course, absolutely compatible. No. Another remarkable point is the balance in the short circuit current that this module is owning, because it's around 10, 11 amperes. So it's widely compatible, and it's a low value, which is bringing us low losses on this regard. The product based on 166 millimeter wafer, it's called again X20. It's owning a higher power output. It's reaching 460 watts. It's the most demanded module for commercial and industrial installations. It's suitable also for utility scale installation, because it's suitable due to its dimensions for plants in locations containing high wind loads. It's owning again a good balance between the power, the size and the weight. It's the better balance in this regard, and as mentioned, it's the most demanded. The big one, it's based on 182 millimeter wafers. It's reaching 540 watts. This is nowadays the power output that we are able to reach in the 72 thels version, and the 78 thels version, it's reaching 585 watts. This is a model that we are launching nowadays, and well, this kind of large format based on 182 millimeters is the most demanded models for ground mounted, with a huge demand nowadays, I have to say. It's the maximum power output that we are offering in our portfolio, with a contained short circuit current reaching 14 amperes, which is absolutely compatible with the common or the standard equipment, electrical equipment that we are using in PV installations, such as the fuses, the diodes included in the modules, and of course compatible with the mainstream inverters. But due to the high power output, it's offering the lower LCOE because of the savings that it's causing in the BOS. In the fourth block, we would like to show you why M10 module benefits. It's really positive for the European market. The M10, it's owning a good skills looking at the handling and installation, the system performance, the product profile, and the load capacity. I will explain why M10 is the best choice looking at these 4 points. Looking at the load capacity, the aim is to keep the product reliability and the traditional loads capacity that we were offering. But obviously, increasing the size guide us to take some considerations. The load capacity, it's mainly determined by the glass and the frame, okay? At the premises of 2 millimeter glasses and reasonable control of the frame cost, there should be a limit for the size of the module, and it is effectively below 1.2 meters. I need to remark that for these wider products, we develop new cross sections for the frame, and also we are increasing the frame thickness to improve the momentum of inertia, which is helping to reach the capacity. Based on this analysis, the frame stress of 182 millimeter wafer modules, we can see it in the graph in the bottom left of the slide, is within the safe limit under the loads expressed in this graph, with a length of 2.45 millimeters and a length below 1.2 meters to reach the 5,400 pascals that we were offering previously, and we are offering now, because we're effectively below those limits in the length and the width of our 182 millimeter wafer modules. The other important point is the glass, and this is because of the weight of the glass. There is a limit of deformation caused by this weight, and we understand that this deformation should cause a power attenuation below 2% to be an acceptable value. Okay, if we are increasing the width of the glass above 1.2 meters, the attenuations, and you can see in the other graph, will reach 5%, which is not acceptable. So again, this number of 1.2 meters, it's over the table to reach the best value of the width of the module, and this is reached by the 182 millimeter modules. Other important point is the handling installation, because in this width that we are proposing, 1.13 meters, the module can be handled by one person in the short side. And yes, well, also the weight of these modules are contained, because we are offering 26 kilograms for the 72 and single glass, and below 30 kilograms for the double glass module. Looking at the product profile, the increasement on the area of the cell when we were migrating from 166 millimeter to 182 millimeter, it's in the similar range of the change that we did going from 158 to 166. It's around 20% of the area increasement. It is proving that 182 is the optimal way to increase the power output on this new modules generation. The dimensions, the weight, and also the electrical parameters are growing in a reasonable way to reach more power output. It's again coming up the short circuit current that I mentioned before in a contained value of 14 amperes instead of going to above numbers or higher current numbers, which is bringing to the module more internal losses, as I will explain in the next slide. Looking at the manufacturing challenges that we were facing with these new products, the manufacturing lines technologies are just slightly changing to be adapted to 182 millimeters. Therefore, it is not compromising the reliability. This is really important for us, the reliability, not changing things massively and not getting the proof enough to launch to the market a reliable product. For the system side value, it's all based on the power output that we are now able to provide, and it is causing BOS savings because of the change in the racking system, because we are allocating more power in the same space. The cabling, it's also reducing the number of cablings that we need to run out of the strings to reach the inverters, and also the labor. Again, because we are allocating more power output. There is a table there comparing different technologies, and it's proof by this analysis that the best BOS cost or the lowest BOS cost, it's given by the 72 cells based on 182 millimeters. All these assumptions that when we were analyzing M10 between M10 or other bigger cells, all these assumptions were enough for us. But in any case, we would like to understand if our assumption about the internal current in the M10 and other bigger cells modules were really causing a higher temperature and losses on this regard. On this purpose, we have been cooperating with Tube North, and we are conducting a 1-year outdoor solar project where we are monitoring which is the performance of this installation, and also which is the inner temperature of the modules using different sizes of the wafers, just to prove or to check if our understanding on this regard it's a good understanding. And we have detected that bigger cells with larger current modules, they are containing an internal temperature of about an increasement in the temperature compared to the 182 millimeter modules of 1.7 degrees. And it is causing a reduction in the performance of the same amount, 1.7 higher performance, more yield we are able to provide. You can check in these graphs, the orange bar is for 182 and the blue bar for largest current module, it's slightly below. In the bottom right, there is a graph of one day, one typical day with a good irradiation. And due to this higher current, the temperature is higher, and also the current, it's dissipating the losses by heat. So the performance is slightly different. No? The modules are performing better with lower current. And now, just a couple of slides to talk about the future. This is a trending topic nowadays, and of course, JA Solar is there. No, we would like to talk how to keep improving or how to keep increasing the power output of the modules. There are two ways. We are working on increasing the module efficiency by reducing the cell spacing. There are several technologies in the market available for it. We are working on our own technology. And the other way is to switch to N-type cells. Why? Because the maturity of P-type cells, it's almost reaching the end, the flat part of the curve. And the way to keep increasing the module efficiency is to migrate to N-type technology. But it is showing, of course, as you may know, some challenges, no? Because these kind of cells, they are having a different way to manufacture the cells, and this is containing more steps and more complex steps. In any case, it is really proved, or it's well known, that this is the technology for the following years, and of course JA Solar is on top of it. We are working on our N-type. We call it Bithium cells. The module efficiency that we are expecting, it will be near to 23. And we are in parallel also working on heterojaction technology, which is bringing other benefits. For example, the N-type, it's, of course, it's a good technology. It's reducing the degradation in the first year and yearly degradation. Also, the performance of low light performance, it's better than P-type. The temperature coefficients are better, and therefore the performance in high temperature is almost, it's also better. And heterojaction, which is bringing another benefits, combining again or improving the low light performance even more than the common N-type. This is a roadmap that we are working on N-type. Our product called Deep Blue 440, it's based on N-type cells that we call Bithium. And we are expecting in the biggest formats to reach more than 620 watts. This is now, we are planning to launch these products by the next year, as you can see in the roadmap. And the following years, the next generations of heterojaction or even perovskites of tandem cell technology will be reaching there. JA Solar will be there when the technology is mature. Of course, we will be offering there, but always keeping the reliability and the warranties of our products. And again, with the aim of provide a good solution for every single application, PV application around the world, and especially in Europe. So that's all from my side for today. Thanks for your attention. And yeah, I bring you the word, Liam.
Excellent. Well, thank you very much, Ignacio. That was absolutely fantastic. We can now open the floor to our audience for questions. So once again, if you do have a question for JA Solar today, or indeed Ignacio in particular, please use the dialog box on your screen. We do have some questions to get us started from the audience that we've been gauging throughout the webinar. I guess, Ignacio, just to get us started, this is quite a present theme from some of the questions. How do you address the reliability or the drop off of performance over time, and how does that kind of impact on the warranty as well?
Well, of course, our after sales department, it's always reporting the defects that we are finding. That I can say it's not a lot of defects to the manufacturing department. To bring this knowledge to the manufacturing sites and try to address these effects and solve them before they occur. This is how the reliability is improved day by day. And it's also important, again, to remark that this knowledge it's coming to us from different situations. So we are able to include in our products a solution in terms of the reliability for all the environmental conditions that you can find worldwide.
Excellent, excellent. And one of the key kind of themes throughout the presentation today has been the product portfolio that JA Solar has, and it's obviously very wide. How does that, is there any kind of problem that creates in terms of compatibility with the rest of equipment that is used within a PV system, whether that's inverters or mounting systems or anything like that?
Mm-hmm. Yeah, this is a good question. It's something that it was a big concern for us while we were designing these bigger models, bigger in terms of the dimensions, but again, based on the same technology. So the compatibility, we will need to check the dimensions for the mounting systems and mainly the current, because the voltage is not changing, at least not changing in a big number. So the current with the inverters and the rest of the small equipment that we are using in the application, such as the fuses, the combiner boxes, the diodes, something like that. No, so probably the major challenge was for the mounting system because of the dimension, and it's something that we were below the limits in terms of the dimensions to be compatible with the mainstream mounting system. It's something that in the beginning was a concern, but after that, with the same product ranges, the market started to use these big models and prove by the use of them that there were not problems of compatibility. In any case, we had this already checked in our design stage, talking with the mainstream mounting system and inverters providers. So no problem. It's absolutely ensured, the compatibility.
Great. And one of the last slides that you showed was JA Solar's almost product roadmap, embracing some of the new technologies that we've seen coming down the line. What is the main difference then between Ntype and P-type modules, and how does that impact on the manufacturing process?
Yeah, it's again a good question, and it's something that is important for the market to understand. The manufacturing process, it's absolutely different. Okay, not absolutely. Sorry, it's including more steps and it's including more complex steps. So the Ntype cells are based on the different technologies, and the ingots are made from a single crystal. Okay, this is different than the P-type. It's bringing the benefits for the performance and the behavior of the cells, but it's all these benefits are impacting also in the cost of production. So to manufacture this kind of cells, it's something, we can evolution our technology, our manufacturing lines, and we are working on it, but the difference between the cost of these technologies, it's existing. Okay, it's something that we cannot avoid. We cannot avoid because it's more complex. We are working to improve this difference, but the difference is there. In any case, all this cost difference, it's absolutely offsetting by the increasement on the yield that these Ntype cells are providing to us. Okay, because of these benefits that I mentioned. No, the better degradation, or the lower number for the degradation, it is creating more incomes in these PV applications. So we can, offset this increasement in the cost. And also the better performance due to the low light behavior, which is impacting in the beginning and the end of the day, and also the high temperature behavior, which, well, it's not happening in all the places, no, but it's something valuable as well.
Perfect. We've got quite a few more questions coming in, so I'll try to get through as many of these as possible in the time we have. Ignacio, are you seeing any kind of product differentiation for residential and CNI and large-scale PV systems, whether that's a different bill of materials, different safety concepts, or anything like that?
Not in terms of the materials compounding the modules. Yes, in terms of the design or the layout for the cells, the large or the small formats. Of course, for residential market, we would need to to fit some different shapes. No, it's not like a white paper like the ground mounting system. So probably the small formats are more suitable for this residential installation. Also, the full black series that we are offering are related with the aesthetics of the models. And yeah, as I mentioned in those slides, it's really the result of using this kind of models. It's really nice in terms of the aesthetics. So no difference in the materials, but using the small format, it's easier. It's easier also to install the modules in the roof, where you can be more limited in terms of the equipment, the lifts, the cranes, that you are using. So the small formats and also this full black could be a difference for the residential market.
Excellent. And I guess we've got time for one more question, I think. One of the points made during the presentation in Ignacio was that 182mm wafers have better productivity than others on the market, thanks to the lower current that they have. Is there then any comparison between 182 and perhaps 166 or other wafer sizes?
Mm-hmm. Well, it's not, I would say it's not a different in the performance, because both of them are based in the same technology. It's more a different in the power output, and it is impacting on the design of the plant. And you could be, well, actually you are saving cost using more power output, but the performance of each of them, as they are based in the same technology, the performance is the same. It's the same. It's almost the same. I say almost because the current is different and the different conditions of each parks is different to compare. But it's not a difference in the performance. It's a difference in the power output. And this major power output could cause a reduction in the BOS. That's the reason, but not the performance.
Fantastic. Thank you very much, Ignacio. I'm just looking at the results of the poll that we ran today during the presentation, which was around, as customers, what do you value most when selecting a PV module supplier? We had a couple of options on the screen. From looking at the results of the poll, which you can see on the screen and on the dialog box, it's quite interesting that there seems to be quite an even distribution between the answers, with product power output and efficiency narrowly edging out cost or pricing and brand bankability. So quite an interesting split there between what customers are really valuing when it comes to their kind of module procurement process. Unfortunately, this is all we have time for today. If we haven't got around to asking your questions so far, then we will really endeavour to get or to answer them privately. So if you can indeed leave your contact details, that would be much appreciated. The presentation and recording will be available to you shortly, so keep your eyes peeled on PV Tech for that. Other than that, there's nothing left for me to do but to thank JA Solar and Henning and Ignacio for speaking with us today. And indeed, thank you for everyone for attending today's presentation. Thanks again, and we hope to see you next time.